angles of elevation and depression, and applying trigonometry to real-world problems. In this video, we'll discuss the trigonometry of landing airplanes, the definitions of angle of elevation and depression, an example with only one angle, an example with two angles, the common mistake, and a summary. When an airplane begins to descend towards a runway, it should make a 3-degree angle with the ground. So an observer here at the ground would look up at the airplane at a 3-degree angle. From the pilot's perspective, the angle is 3 degrees from horizontal as well. The difference is this horizontal here is real, it's the ground. But this distance here, this horizontal line here, is imaginary. It's just a line of sight. So the angle of depression and elevation are formed with a horizontal line, and in the case of elevation, a line of sight above horizontal, and depression would be a line of sight below the horizontal. Note that the lines may not have a physical component. They may just be imaginary or a line of sight, something that's not really a physical line like the ground or a string or a wire. If there's an observer at both points, at the high point and the low point, each viewer would see each other at the same angle. So if we have a person up here looking down at 38 degrees with an angle of depression, so angle of depression looking down, the person at the bottom would look up and see them at a 30-degree angle of elevation. They're looking up. So here's an example. We have Romeo looking up at a 50-degree angle of elevation, and he's standing 10 feet away from the house. And if here's Juliet, Romeo, Juliet, how far above the ground is Juliet standing? Well, as long as the building makes a right angle with the ground, we should be able to solve this using our right triangle trigonometry. We know the adjacent side to Romeo, and we're looking for the opposite side because that's going to help us give the height. We don't know the hypotenuse and we don't care about the hypotenuse. So if we're looking at O and A, that means we're going to need the tangent ratio for 50 degrees. And that will be equal to, let's call that lowercase h for height, over 10 feet for the adjacent. When I cross multiply, let me kind of mark off where I'm working here, I'm going to do 10 times the tangent ratio of 50 degrees, which will give me my height. So my height would be about 11 feet, but we need to also include Romeo's height. So saying he's about average height, so that would be about, let's say, 16 feet 7 inches. In a problem, I would give you this height if I expected you to calculate it. But the next problem is a little bit longer setup, and there's going to be two angles for us to handle here. Batman is standing at the 5th floor window, 60 feet above the ground. At a 40-degree angle of elevation, he sees a helicopter approaching the building. Directly beneath the helicopter is the Batmobile, which he sees at a 70-degree angle of depression. He's trying to decide on which to use his grappling hook. How far is the Batmobile from the building, so that's a distance along the ground, and how high above the ground, directly above the ground, is the helicopter? This is what the diagram of this problem would look like, and I'll add a little bit of notation here. He has a 40-degree angle of elevation, a 70-degree angle of depression, and he's 60 feet above the ground. So we want to know two things. We want to know the distance along the ground to get to the Batmobile, so I'll call that D, and we would like to know the height above the ground for the helicopter. Let's call that H. So first what we're going to need to do is solve this right triangle down here because I have the most information about it. I could label it over on this side and use this triangle, or I can use this triangle over here against the building. Either one will work. Here's the setup. Tangent of 70 over 1 equals 60 over d. When we cross multiply and divide, we get d is equal to about 21.8 feet. So that gives us the answer to the first question. It's 21.8 feet away from the wall. In order to solve for the height, we also need to solve for this height right here. We already know this piece is 60, so we just need to find out this remaining piece up here. And we already know that this piece is 21.8, which gives us the two sides, the known side of the triangle and the unknown side of the triangle. So we can set this up again. We're going to be using tangent, but this time of the 40-degree angle. And this time we're solving for the numerator. Solving for this side, we get 18.3 feet, which makes the helicopter a total of 78.3 feet above the ground. It's a very common mistake to try to draw these lines with the vertical. However, these angles are always drawn with an horizontal line, never with the vertical. So that's a big no-no. This one over here is the correct version. So don't forget to summarize, a quick summary of the definitions and the most common mistake. Make sure you know which kind of line these angles are always drawn from.